we are asked to find all the possible rational zeros and factor f of x. So the first thing we're going to do is we're using the rational zeros theorem, and that says that you take your equation and you take the factor of the last number, so the number without a variable. So in this case, that's 15. So, and then you take all the factors of the leading coefficient, so whatever your highest exponent is, in this case 1. So what are all the factors of 15? Well, there's 1, 3, 5, and 15. And 1, of course, is just 1. And then it's p over q, where p is from the last number and q is from the first number. So it's a little bit reversed. I kind of in my head always sometimes think that p should be the leading one because it's on top, but it's actually backwards. So this then is plus or minus 1 over 1, which is 1, plus or minus 3 over 1, which is 3, etc. So plus or minus 5 and plus or minus 15. So these are all our options for the rational zeros. And they're always the positive or negative version of them. So now to find the rational zeros, what we're going to do is we're just going to check all these. And we know that we should have 3, at most 3, because we have a third order. So we're never going to have more than 3. You could have less if you have a double, but you're never going to have more than 3. So what I'm going to do is I'm just going to use synthetic division, and I'm going to start checking. So like, for instance, I'm going to check 1 and negative 1. So you can see this. I'm going to write this out. This is 1, negative 9, 23, negative 15. And what you're doing is you're looking for the ones that give you a 0. So you can see this is 1, 1, negative 8. Negative 8 is actually 15, 15, 0. Yay! So right now we have 1. Then we're going to go on and we're going to check the next one. So now we're going to do negative 1. And you're just going down the line until you find them all. And it might be the last one that finds them. It might be one earlier. Just like factoring, when you're choosing all yours, obviously pick the ones you think are most likely. That obviously doesn't mean it's going to be the right one. So then this is negative 10, 10, 33, negative 33. No. So that one is not. I'm going to change colors just because it's more fun that way. And now I'm going to try 3 and negative 3. So 3 and 1, negative 9, 23, negative 15. The nice thing is obviously this is never going to change, so, kind of once you get going. 3, negative 6, negative 18. So it's 18, 5, 15. Ooh, cool. This is another one. So now we're up to 2. So at most we're going to have one more, so we're at 1 and 3. Here I need another page. Hopefully here. So I'm at 1 and 3, and I just chose, so let's try negative 3 now. So negative, I want it to allow me to write, negative 3, and what were my numbers again? 1, 1, negative 9. So once I get going, it's going back and forth. Obviously, you're not going to have this problem because you're not going to be trying in negative 15. Okay, 1, negative 3, negative 12. This is 36. So this is 59, and this is some huge number, so that's not going to work. And obviously, once you realize, oh, hey, it's not going to work. Okay, and now I want to try 5. So 5, 1, negative 9, 23, negative 15. So I'm going to bring this down 1. This is 5, negative 4 gives me negative 20, 3, 15. Yay! So 5. So my third answer is 5. And at this point I can quit. I know I'm most going to have 5, only 3. So hey, I'm done. I've got my amount. So 1, 3, and 5. So B. And then writing this out, remember they're just the opposite signs. When you were factoring, if you got x minus 3, you knew when you solved that, that was x equals positive 3. So we're looking for, right here, x minus negative 1, x minus negative 3, x minus negative 5. So you can see this rational theorem, this rational zero theorem, allows us to quickly find all the zeros and factor out a polynomial, and especially larger ones that we can't do a traditional method. Now, obviously, you're going to get a lot more possible solutions than there are answers. And so it might take you a while to flip through all the options, but that's what you're going to have to do. And obviously, certainly, order them in the order you think is most logical. Like, for instance, looking at this, I was kind of guessing 15 probably wasn't the right answer, so obviously I'm going to do that last. But if I get through all the 5s and I still haven't tried them, I'm going to try it because I know I could have up to 3 options, so I have to keep trying until I get through them all.